about polynomials. We need to know what a polynomial is. We need to know what a monomial is. So a monomial is one term. Okay? One term. A binomial, you guys just want to look up here for a second, let me explain it and then write. A binomial is two terms. The word, or the prefix bi means two, right? A bicycle has two wheels. Okay? Two terms. So binomials are separated by a plus or minus signs. Titus. Look away. Trinomial has three terms. Our most important one is called a quadratic. We are going to do a lot of things with our quadratic in the next few days, and we're going to learn how to factor them and make and multiply to them and more. Okay? And the last one is a polynomial. So when we have four or more monomials, we have a polynomial. Right? So a monomial is a variable, or it's a combination of a number and a variable. It's just a number. What do we call just a number by itself? Jane? What do we call just a number by itself? Do you remember? See? What do we call a number when it's just by itself? Constant, yeah. So, a variable, a constant, or a combination. Notice these are multiplied together. The 8b squared, that is a monomial because it's combined together by multiplication. If it's added or subtracted, that's what separates things out to make it a binomial, trinomial, or polynomial. Okay? So that's the super, super important part. All right. As we're looking at that, we've got a chart. We are not going to worry about the degree. I took that part off. We are not going to, I don't even think you have this on your thing.
No. Yes, we do.
No, you don't. No. Okay.
You got that on your page.
We have this. But I took the degree off of our chart, so don't worry about this part. So, this right here, without looking at the notes, why is this a binomial? Two terms. How do I know it has two terms? What is there that separates it into two terms?
3x plus 5.
What's
3x
specific?
squared.
3x squared plus 5. What specifically separates it into two terms? The plus sign. Okay? That plus sign makes that two terms. How many terms? 1. How many terms?
3.
3.
1. 4.
Okay? So this first one's a binomial because it has two terms. Second one's a monomial, it only has one term. The third one is a trinomial. That is not a quadratic. We are going to talk a lot about quadratics, a specific type of trinomial. 18 is a monomial, no plus and minus signs in there. Can I move up this far? Good. And then this last one is a polynomial because there's 4 different terms in it. Okay? It's too much. when we are looking to add polynomials, when we're looking to add polynomials, these all say plus signs, we need to think like terms. Okay? So this term right here is defined as an x squared y term. X squared y term. Right? What is this one? The same thing. How many are in this first pile? How many x squared y's are in that pile? There's 3 in that pile. How many are in this pile? 2. How many of those do we have all together so far? 5. Is this a like term with that? Yep. So then, how many of those do we have all together? 7. So we have 7x squared y. Is this a like term?
Yeah.
Nope.
No.
Because this is an x and y squared. This is an x squared y. The exponent has to be exactly the same. With that exponent being exactly the same, then you can tell if it's like term or not, right? So this one's different. So this would be x, y squared. That is combined. You have combined what you can combine. Stuart, you should write things down. If you can't see, then you should move. Okay? What about this one? 3x plus 1 plus x minus 2. Is there a reason why those parentheses are there?
Yes. No.
In this case, there isn't, because everything's being added or subtracted, right? If they were being multiplied, that would be different. If that plus sign in between here wasn't being multiplied, then it would be okay. So what are our like terms? Sure there are.
The 3x and the x.
The 3x and the x. So one way you can do this is you can just move them into different positions. So this is a 3x, this is a positive x. My 1 is over here. What's that number? Negative 2. Okay? So then you can combine them. That's one way to do that. Another way is to align and add, which I'll show you in a minute. Okay? So how many x's do I have all together?
4.
There's 2 terms that have x's in them, but there's 3 in this pile and 1 in that pile. Okay?
4.
So 4. So be careful of that. Remember that this number up here defines how many x's are in that pile. So yes, there's 2 terms that have x, but 4 altogether. How many constants do I have? What's my total for my constants? 1 plus negative 2. Negative 1. Okay? Okay, can you do that? You be able to do that? Titus, put your phone up front. Another way that you can do this is to align and add. I don't know if you needed to throw it, since you can't stay off it. Okay? Align and add means that you put the like terms underneath each other. Okay? So, this one stays here. You look at the second. Ready? Look at the second set of terms. And we know that x squared and x squared are like terms, right? So you're going to take this and you're going to rewrite it underneath here. But you're going to line up the terms that match each other. Sometimes what's over here doesn't match the order of this, so you need to think about what order they need to go in, okay? So x squared is going to go under x squared. The x is going to go under the x. The negative 2 is going to go under the 3, and now I can add those together, kind of like what we were doing in chapter 6 when we were doing elimination, right? So we can move this underneath here, and then that's not there anymore, and we can add them together. So that is one method that you can use to do this. How many x squareds am I going to have all together? How many are in this first pile? This pile? 1. How many are in this pile? How many are there all together? Plus? How many x's? 3x. Does everybody see where Paul got 3?
No. X on itself.
There's an imaginary 1 there. 2 plus 1 is 3.
If you don't like the ones, go to sophomores.
Yep. So 3 minus 2 is, or 3 plus negative 2 is,
1.
is 1. Positive, right?
Yeah.
So that's my answer. So that is a way that you can do this. You can do a line and add. All right? Another way that you could do this is you could use different colors or different shapes. So 2x squared is a square. Negative x squared, keep the sign with the term. You can add those together. You can add those together. You can add those together. As we get further along in the chapter, and with certain other topics, a line and add is easier if you're consistent, but you decide how you'd like to do it. If you'd like to go across and then add together like terms like that, that's fine, and go from there. What would my answer be here? If you want to do a line and add, then put this underneath in the appropriate spots, and then add them up. What would my answer be here? These are the 3 answers that we've gotten in the room. Let's talk about why the ones that are correct and why the ones that are wrong, okay? So I'm going to align and add this because I feel like you might do better with that. All right. So I like this first one. Right? How many are in this pile? How many x squareds are in this pile? 2. How many x squareds are in this pile?
1 x squared.
Negative 1.
Negative 1 x squared, yeah.
So if I've got 2 things in the pile of x squareds and I take one of them out, how many do I have left? 1. Right? So I've got 1 x squared. Here I have how many in this pile? 1. How many in this pile? Negative 4. 1 plus negative 4 is?
Negative 3.
Negative 3. Okay. And then negative 3 plus 2 is negative 1. So you all got, here's what's interesting. You all got this part right. But you struggled with the first term. So when you're looking at that first term, I want to especially talk about this one because this is a very, 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 very common mistake. Okay? Why are you able to add these two together? The 2x squared and the negative x squared. because they're like terms. Is this a like term of that like term? No. Okay? Although in chapter 7 we learn to add exponents sometimes, we don't add or multiply exponents when we do this. We're combining them because they're x squared, or because they're x's, or because they're constants. So the exponent does not change, only the number in front, which is called the coefficient. Remember the coefficient word? So only how many you have of them changes, not the exponent. Okay? This is a very common mistake that people make, and what's funny is they only do it on the first term, and I don't understand that. Everything else is always the same, just the first term is messed up. Every single time I see this mistake. So be careful of that. Be careful that you're adding correctly when you have a negative. Okay? That's a negative x squared. Don't lose that negative. Good job. Did you guys do the last one? Number 3?
I'll do the Titus.
Okay. So Titus got 11x squared, what? Plus x minus 2, which was an alarming answer for the last problem. But it's a good answer for this one, right? 4 plus 7 is 11. 3 plus negative 2 is definitely 1. 2 plus negative 4 is definitely negative 2.
Yeah.
Okay?
Yeah, I got the same.
Excellent. All right. On the worksheet, please pay very close attention to number 9. Think about what you're doing. I would do a line and add on that one, especially since you're just starting this. So you're going to put both of those other 2 polynomials underneath the first trinomial. And you are going to make sure that you line up like term to like term. Don't write them. Look at number 9. In the first trinomial, it's 4x plus 2y minus 6z. What's the second trinomial start with? You're looking at number 9 on your worksheet. Everybody, what's the second trinomial start with? What do I mean? What's a trinomial?
2z.
She just says.
Oh, I mean 5y.
5y. You're looking at number 9, right? The trinomial is that group of 3 in parentheses. 5y is what the next one starts with. What did the first one start with? 4x. So you're going to put that 5y underneath the 4x? What are you going to put it under?
7x.
You're going to put the 7x underneath there.
Just like switch around the numbers.
You're going to switch around the terms so that they're underneath the term that they need to be under.
So you start off with the first
Okay.
2 and then you add the third one, or you just do all 3 at once?
You could do what I did. I listed all 3 of them underneath. So I left the first one there and then listed the, yep, just like we've done since a long time. Okay? All right? So be careful